And good morning, grade 9. We are going to get this week 10, chapter 2, lesson 3, elements and compounds, part 1. And we are going to know what is the difference between the elements and compound there, and how we can differentiate between them and get a lot of properties between the elements and compounds. Let's start. First question saying distinguishing elements and compounds. So how are elements and compounds are different? How to differentiate between them? So substances can be classified as elements or compounds. So beginning, we will say what is the element? The element is the simplest form of matter that has a unique set of properties. Like oxygen and hydrogen, they are different separately elements and also are two of more than 100 known elements. And for example, we'll say a compound. A compound is a substance, so it has a uniform structure that contains two or more of the elements chemically combined in a fixed proportion. So for example, when we get the hydrogen as an element and the oxygen as an element, they are separately elements. But when we make them together, come together, by a certain fixed proportion, 2 hydrogen to 1 oxygen, it will be water molecule, which is a compound too, and they are chemically combined with a fixed proportion. So we can say that water is a compound, but the hydrogen and oxygens are, elements. Let's get another example for illustration. That's carbon and oxygen and hydrogen are chemically combined in, chemically combined into the compound of sucrose. Sucrose is a type of sugar, table sugar. We use it for tea and coffee and something like that. It's called scientifically sucrose. And if we said that in a very simple one, we can say that in every sample of sucrose, there are twice as many hydrogen particles as oxygen. So if we said that we have 1 oxygen, we will get on opposite 2 hydrogen in this compound. And accordingly, the proportion of hydrogen particles in sucrose is fixed. So for that, we'll get there is a difference here, or a key difference between the elements and the compounds, that compounds can be broken down into simpler substances by chemical means, but elements cannot because they are the simplest form. Yeah, let's get to the property of breaking down compounds. Physical methods wouldn't work in this area because we wouldn't use the physical methods in order to break the chemical combination between the elements to make the compound. So if we, for example, start to boil water, it wouldn't, get back to oxygen and hydrogen because that's a physical change. It will change into vapor only. But on the other side, physical methods cannot work. When you get to dissolve the sugar inside the water, it will start to change from solid state into another type of liquid state, which is aqueous solution of sugar. It will then start to break down into hydrogen, oxygen, and carbon, the main elements of it. These all are called physical methods to separate. It's not applicable. The applicable one is a chemical change. So the chemical change is a change that produces matter with a different composition than the original one. So if we start to get that in consideration, so breaking down the compounds will get some heat directly. So if we get some sugar and put them in the pan like you see here in the first one to the left, and start to make it start to heat it and burn it up till it start to turn into carbon, and the water start to go out in form of water vapor, as you see here and here too. So that is the way of breaking down that one. So heating must be chemical change. Here also, if we get to the overcooked toast here, the taste of it start to change because it will get a little, crust of carbon when you overcook it. And when the taste change, it means that the composition changed. So that's a chemical change too. Yeah. Mostly the cooking is chemical or burning things or heating things here. So What happens here that the compounds inside undergo chemical change that changes the taste of the bread into, solid carbon when it starts to burn. Also, and substances that are produced when sugar is broken down when heated also be broken down. Yeah, exactly. There is no chemical process that will break down carbon into simpler substance because it's an element. But if we get to that, so that's how to break down the sugar into its own elements. So in the beginning, we use a chemical change, which is heating, and the heating here start to get the sugar into the first element, which is carbon and water. And by the end, the water can be changed by electricity or applying electrical current for it. So when you apply electrical water, it will start to break down into hydrogen and oxygen gases. So we get the three main elements, carbon, hydrogen, and oxygen, by using two processes of chemical change, which is heating and applying electrical current. The properties of matter too, of compound, in general, the properties of compound are quite different from those of their component element. So for example, sugar is sweet tasting, yeah, white solid, but when I break down it by heating, the carbon that comes from it is tasteless and black solid. So they are quite different from each other. Also, guys, when we get to the hydrogen, it's a gas that burns in the presence of oxygen. The colorless gas supports burning, that's oxygen. And the product of this chemical change when start to react together, hydrogen and oxygen, they give you water, which is a liquid that can stop the material of burning. So that's opposite function of both. One is going to start to burning and the other is going to stop burning. So that's quite different. So the elements and compounds have different properties from each other. Also, let's get to the properties of compounds. For example, again, when elements like sodium, the sodium here is like this solid metallic, soft one metal. Yeah, and that one is a gray soft metal, also getting its own properties. We can use it in the alignment sometimes. And on the other side, we get the chlorine, which is a yellow poisonous gas. So sometimes we use the chlorine in order to start to clarify the water in the swimming pools, but it's a poisonous one, and the sodium is toxic. But when the sodium and chlorine start to come together, they make the sodium chloride, which is table salt. We use it every day in our life, and it's edible, not toxic, and not also poisonous. Yeah, not metal and not gas too. That's solid with a white color and edible for all of them. Yeah, so when we ask ourselves a question, can elements be broken down by chemical changes? And can compounds be? Yeah, if we ask ourselves this question, elements cannot be broken down because it's the, as exactly as you said, guys, before, the simplest form of matter. But the compounds can be broken down because they can chemically change and get back to their own elements. Another thing about distinguishes substance and mixtures, we have to know what is the difference between the substance and mixture. So for example, more illustration, deciding whether a sample of matter is a substance or mixture based on solely the appearance can be difficult. So we cannot get it from the appearance or the shape. But after the homogeneous or homogeneous mixtures and the substance will both appear to contain only one kind of matter because it's one phase for each. But if we decide to see that, for example, guys, that's not based on the appearance. So sometimes we decide to consider, yeah, whether it's all more of one version of the material is a question to ask yourself. For example, if we get the milk, we have more than one type of milk depending on the mixing between the cream and the milk. So we got whole milk, we got low fat milk, we got no fat milk, and we get light cream, and we got heavy cream. All of that, guys, are differently according to the way you mix them. So once we get this idea according to the mixture between the milk and cream, so that will be a mixture if it contains more than concentration for that, mixing. On the other side, if we get the gasoline in the gas station, there will be more than blends of gasoline that contain different octane number, like octane 91 and octane 95 gasoline. They are differently, uh, so that depends on the mix between them. So that's a mixture. On the other side, if the composition of the material is fixed, so we can call it substance. If the composition of the material may vary from one to one, so that will be a mixture. For example, that's for illustration. That diagram is easily to understand, guys. If we start to divide the matter into two branches, so it will be either substance or, yeah, mixtures, exactly. And we will get the substance as homogeneous, indefinite composition, and uniform one. But on the other side, the mixture, yeah, they are substance with variable composition, more than one substance. So when I want to start to get the mixture into their own starting original substance, I can do that by separating them by physical change and physical processes. If we get back to the substance, it might be an element or a compound if it's more than one element combined chemically together. But if I want to get the elements, yeah, that originally this substance come from, I can do that excellent the gas by separating it chemically. Like we said in the sucrose, we separate the sucrose into carbon, hydrogen, and oxygen by heating and by electrical current. So that is chemically changed. And on the other side, mixtures, yeah, we can get the mixture in two types. One of them is homogeneous and the other is heterogeneous. And we said before in the last session that we get the homogeneous uniform also is called solution, and the mixture that is non-uniform, distinct phase, it will be more than one phase, it will be heterogeneous, like we mix excellent oil and water. But here when we get, yeah, salt and water or sugar and water and mix them together, there will be one phase. And also when we get olive leaf and we get vinegar, which is acetic acid and water, that's all homogeneous mixture. So thank you guys for your time. Next time we will get the part 2 about classifying materials and how to know if the material is element and compound, and how to get the symbols and formulas of elements and compound. Thank you for your time, grade 9. If you please get back to pre-serialize, and thank you for your work, guys. And I need you to exert more efforts, be safe home, and study well. Goodbye.